This is a Friday Shoes production. This is lesson 7-1 in our books on page 352. The target is I can find the circumference and area of circles. So we're talking about circles today. I would draw this picture here on the right into your notes and make sure you label each part. You notice there's a radius, center, diameter, circumference, and I would listen to me as I read this to you here and look at that picture. It says a circle is a set of points in a plane that are the same distance from a given point in the plane. A plane would be a two-dimensional space, which is kind of like a piece of paper. And those points are all equidistant from one point called the center. Now, the segment from the center to any point on the circle is called the radius. And you can see these pictures as I read, or the locations of these pieces as I read this to you. A chord is any segment with both endpoints on the circle. Now, that's the one thing they don't have a picture of. Let me draw one for you in blue here. If I were to just take, let's say, a point here on the line, on the circle, and then another point here on the circle, and I connected that, that's called a chord. Now, a diameter is a chord that passes through the center. It has a special name. It's called the diameter, and it is the longest chord. Now, they also say that the diameter of a circle here is twice its radius. So you notice here's your radius, but if I were to draw another one this way, now I've got this long piece, and of course that would be called a diameter. So again, if you double a radius, you have a diameter. If you cut a diameter in half, you have a radius. All right, how about here on the bottom? It says the distance around the circle is called the circumference. So, and when we deal with polygons, we ask for the perimeter. That's the distance around that figure. Now, in circles, we use the word circumference instead of perimeter. And again, it's just the distance around the circle. And listen to this one. It says the ratio of the circumference of a circle to its diameter is always 3.141592653. It keeps going on forever. That's pi right there. So what is pi? And you see here it says represented by the Greek letter pi. But what is pi exactly? It's the ratio of the circumference of a circle to its diameter. Let me write that over here. Ratio, again, we use a fraction bar. And ratio is, it says the circumference to the diameter. And if you look at that, that just means divide. So if you take the circumference and you divide by the diameter of any circle in the whole world, you will get pi. So measure any circumference, divide by its diameter, and you will get pi. Again, it's represented by the Greek letter pi there, pi, and they show you the picture. Now, the number 3.14 we use is kind of an estimate. Also, you can use 22/7, and that you'll learn more about in high school. But those both represent an estimation of pi. For our purposes here, we typically will use 3.14 as an estimate. Now that we know that circumference divided by diameter is equal to pi, you can see they actually have that written here. Circumference divided by diameter equals pi. This also can be written like this. The circumference is pi times diameter, or you can write it as 3.14 times diameter. And we're going to use this information to actually figure out math problems. So let's look at, again, the circumference of a circle. It says here, the circumference of a circle, C, is equal to its diameter, D, times pi. Or, if you have a radius and they don't give you a diameter, then you take the radius, double it, or times it by 2, and then times that by pi. So these are the two formulas I would write down in my notes to know if I'm looking for circumference, I need to know the diameter or I need to know the radius. In that case, I would double the radius and then just multiply it by pi. All right, example 1 here. It says find the circumference of circles. Find the circumference of each circle, then of course round to the nearest tenth. So they've got a circle here, and it looks like they gave us the diameter, not the radius. So we have the diameter. So I'm going to use this first formula up here to do it. And here is the work that is behind it. If you look, they're saying use this information right here, this formula, plug in the 9, which is your diameter for the D, and then, and I want to point this out here, when we actually multiply 9 times pi, and that's what you're doing, 9 times pi. We can leave it like that, and that's called pi format. You'll see that again in high school. And I think even the MCAs, they have a question that says write it in pi format. So all that is just how many pi's do you need to multiply to get to your answer. In this case, we're looking for the circumference, 9 times pi. And what is the answer to that? Well, use your calculator, and they show you the calculator sequence there. You push in 9 times, and then you have to use the second button. Use the pi button if you're using the TI-30. You hit enter, and you get that long decimal that goes off the screen. And the reason why is pi is an irrational number. So we need to round this, it says, to the nearest tenth. So if you notice, we have a 7 right here. So we're going to want to round this one to a 3, because that's 7 is 5 or greater. So the circumference is 28.3 inches. Again, all we did was plug in 9 for the diameter and then multiply by pi. How about this one? On the circumference of this one, notice this one actually has the radius given. The radius is 7.2. So now we're not going to use that first formula. We're going to use the second one that has the radius in it. This one right here. And all you have to do is, what you're really doing is taking your 7.2, plugging it in for r, and you're doubling it to give you your diameter, just like the first one. And then, of course, you multiply by pi. You can do it in the order they have it here, 2 times pi times 7.2. You're going to get your calculator out anyways, and you're going to round out to 45.2. So we would say that the circumference is about 45.2 centimeters. We don't write down centimeters squared. This is a linear distance, even though it's circular there. It's going to be not square units. It's going to be linear distance, as we say. It is a distance. All right, how about you give it a shot on these two? Pause the video, try these two, come on back, see how you did. All right, the first one, it says find the circumference of each circle. Or the first circle here, we have diameter given to 6 feet. Well, we know that circumference is equal to pi times the diameter. That's one of the formulas we have. So all we need to do is plug 6 in for D. And when we multiply 6 times pi, that's 6 pi's. What do we get? Well, we get, and this should actually be this right here. I should change this to approximation. So we have, C is approximately 18.8 feet to the second power. How about the second one here? We got 11.7 meters. What is that, the diameter or the radius? That's the radius. Now notice again, this is the radius, this is diameter. So we have to use a different formula for that. And that formula, of course, is 2 times pi times radius. That'll give it to you. But yet again, we use it because we have radius and not diameter. So let's plug in 11.7 in for our R. And then multiply these three numbers. We have 2, we have 3.14 if we want to use that as our estimate, and then 11.7. When we do that, we have an approximate answer of, and I'm going to change that again, approximate answer of 73.5 meters to the second power. All right. Next piece of information. It says this one, and this is going to be related to the parallelogram conversation we've had earlier. A circle can be decomposed, broken into pieces, into congruent wedge-like pieces, and you can see the picture there. Then the pieces can be rearranged to form a figure that resembles a parallelogram. Oh yeah, it does kind of look like a parallelogram. Let me draw that there. You can kind of see that. I see it there, parallelogram. Now, since the circle has an area that is relatively close to the area of the parallelogram-shaped figure, you can use the formula for the area of a parallelogram, which is base times height, to find the formula for the area of a circle. Now, this is a discovery lesson of how do they come up with the formula for the area of a circle. So if you follow their information here, you can see this pie shape here. This piece right here is the radius, and they put all these pieces together. And if you notice on this side, all these little, little pieces right here, that's going to equal half of the circumference, halfway around the circle. And then the other half would be up here on the top. Makes sense. That'd be the other half. So we have half the circumference. We also have the radius here. So you take a look at what they've done. They take the base. And what is the base? You can see here the base is going to be this piece. It's going to be 1/2 times the circumference, or half of the circumference. And they're going to multiply it by the radius. Now, if you look at that C, they've actually broken the C out into the two pieces that we know, or the three pieces we know. It's 2 times pi times r. So when they actually do all this math together, this 1/2 times 2, that becomes 1. And that's, you might call it cancels out, because 1/2 times 2 is 1. And then 1 times pi times r times r. So you can see all the pieces being put together there. The formula is the area of any circle is going to be pi times radius squared. Or some people might say pi times radius times radius. So there you have it. Let's use it. So the area of a circle. Again, this is the one thing I'd have in my notes for sure. And it's pi times radius squared. Let's actually use it for example 3 here. Find the area of each circle round to the nearest tenth. You have, notice they give you the radius in this case. So that's easy. Take our formula, plug in the 8 for radius, square it, because that comes first. It's the order of operations. We get 64, and then we take 64 times pi, and we have an approximate answer of 101.1. So the area is about 201.1 square kilometers. And notice we now have the square units because it's area. Areas are measured in square units, which we've discussed earlier. How about the second one? Notice they don't give us radius, they give us diameter. So the diameter is 15 feet. So first thing you got to do is take your 15, and you got to find out how much just this part is right here, the radius. Well, take 15 and divide it by 2. When we do that, that equals 7.5 feet. Now, notice that's the 7.5 feet right there. So we take our 7.5, put it in for our r, we square it, we get 56.25. Use our pi button on our calculator, multiply by 56.25, and we get 176.7. So the area is about 176.7 square feet. Again, we're saying about because we have an approximation of pi. We've rounded to the nearest tenth. And there's our square units again. Another way to write that, and we've done that in class, is with FT with a 2 on it. How about you give it a shot here on these two examples? Come back, see how you do. All right. It says the radius is 11 inches, and you're looking for the area of the circle. Like it when they give us the radius because the formula has radius in it. We need it. So we're going to take our 11, plug it in for our r. We'll use 3.14 for pi. 11 squared times the 3.14 is approximately equal to, I got to make that approximately equal. Once we use 3.14, we're estimating. So we've got 380.1 inches to the second power. All right. How about E here? The diameter is 5 meters. Well, I don't like when they give us diameter. That means we got to do a little more work. We got to find the radius. What do you got to do? Well, we do need radius. Here, I'm showing you that we do need radius. We don't have one for diameter. We need to figure out radius first. So let's take the diameter and divide it by 2. That's what radius equals. And when we do that, we plug in the 5 for the D, for the diameter, divide by 2, and we get a radius of 2.5. So it's 2.5 meters. That's what we're going to plug in for R. And notice I highlighted it there. So we'll use 3.14 for pi. We'll times by 2.5 to the second power. And we end up with an approximate answer of 19.6 meters to the second power. Real quick, I want to show you, sometimes they give you what you might call the answer, or they'll give you the area or the circumference, and they'll ask you for either the radius or the diameter. Here's an example of that, and you can see what you're supposed to do here. And I noticed there's something missing. Let me add that in there before I talk about it. All right, so here's what it is. It says, suppose you walk around the edge of the circular point State Park Fountain. I believe that's in Pittsburgh, and you can see the picture of it above. And you estimate that its circumference, the distance around it, is about 470 feet. Maybe you counted by walking around and counting how many footsteps you took. Now, based on your estimate, what is the approximate diameter of the fountain? Because you don't want to walk through the fountain. You can't do that to see how far it is from one side to the other through the middle. But you can do it if you have the circumference. And here's what you do. Notice you're going to use circumference equals pi times diameter. And the reason why is you're looking for diameter and you just estimated the circumference. So you take your 470 that you have, that you counted as you walked all the way around, and you put it in 4C, and now you got 470 there. But you don't have the diameter, and that's what we're looking for. So how do you get rid of this pi? Well, you divide it away. You divide by pi. And when you do that, you got to do it to both sides, and notice that's what we do on the other side. These cancel down, and you'll end up with D. On the left side, you take 470, you divide by pi. And when you do that, you get 149.6. So you would say that the diameter of the fountain is about 149.6 feet, or 150 feet in this case that I used here. There you go. If you have any other questions or want to review this video, don't hesitate to replay it. Or you can, of course, look at the examples in the book, or you can look at some of the personal tutor videos that we have online. And as usual, this has been a Friday Shoes production.